All right, so we are actually 5.6 is going to be in two different parts. So today we're going to be on unit 5.6a. Okay, and we are going to work on solving angle relationships. Okay, solving angle relationships. Now, there's lots of different ways you can classify angles, okay? But today we're going to work on, today we're going to work on three different ways. Okay, so the first one we're going to talk about is something called vertical angles. Okay, vertical angles. Vertical angles are when you have, two parallel lines. Okay, so if there are two parallel lines and you have something called a transversal that's going through these. Okay, so when you're all the angle relationship we're going to talk all the angle relationships that we'll talk about are when you have two parallel lines and then one transversal. So a transversal means it's going through the two. Okay, and it's not parallel, it's not perpendicular, it's just a random line going through the two. Okay? Vertical angles are basically, if you kind of like turn your paper a little bit, vertical angles are when it looks like the two angles are on the opposite sides of an X from each other. Okay? So it could be like these two are vertical angles, okay? And I'm going to show you with these two. Okay, so this one is on a vertical angle with this one. These are called vertical angles to one another. There's lots of them in there, okay? It could be like these two right here, or it could also be these two, okay? So the ones that are like inside an X and across from each other, okay? And what you need to know is if you have vertical angles, to solve, you set them equal to each other, and solve. Okay, so what we're going to do today is I'm going to introduce you to all three different types that you're going to have. Then I'm going to give you problems, and we're going to make sure we know what kind of angles they are, and then how to solve. Okay, so I'm going to show you three different types of angles. First one was vertical angles. Okay, and with vertical angles, you set them equal to each other and solve. There are also posters on the whiteboard. Okay, so posters on the wall to help you remember which ones are which. I will be adding more. Right now there's only a couple. Okay, but I will be adding some more. The next type that we're going to look at is something called corresponding angles. Corresponding angles. Okay, so I'm going to draw basically the exact same picture. Okay, so you're going to have two parallel lines with a transversal. Now, your angles aren't always, or your picture's not always going to look like that. Sometimes it's like a little bit twisted, and that's fine. Okay, I'm just drawing these all the same just so we can kind of have something to compare. Corresponding angles, hopefully you remember what we did on Friday. Okay, when we did on Friday, the corresponding angles are basically always the ones that, like, if you look at these as kind of two plus signs, okay, they're the ones that, like, the corresponding angles were in the top left of both, or the top right of both, okay, so that's how they go. These ones, corresponding angles, exact same thing, okay, so let's say this one right here, I'm going to draw hearts, because I want to, you don't have to. You don't have to draw a heart. Okay, this corresponding angle, where would the corresponding angle be with that? Oh, sorry, you can't quite see. Corresponding angle here is basically you just skip a line. Okay, so you skip over the line and it would be on top of the next one. So on top of the first line on the left, on top of the second line on the left. Okay, those are called corresponding angles. To solve when you have corresponding angles, you do the exact same thing we did with vertical. You set them equal to each other and solve. Set them equal to each other and solve. Set them equal to each other and solve. And then the last type of angle that I'd like to talk about today is something called, something called same side interior angles. Okay, same side interior angles. So we're going to draw basically the exact same picture. So two parallel lines with a transversal going through them. Okay, so two parallel lines with a transversal going in between them. Focus that a little bit. Okay, so same side. When we're talking about the same side, we're talking about if it's on like the left or the right, the same side of the transversal. Okay, so it's either going to be all on this side or all on this side. And if we say the word interior, we're talking about, are they in between the parallel lines, so right in here, or exterior would be outside, like this. So same side interior, okay, same side interior, I'm going to say would be like these two. So right here, and then inside still, right here. Inside on the same side. Now, if you look at this, where would you say is the corresponding angle to this top one? The bottom, like right here? Right here. So would you say that this one, the corresponding angle to this one, would be like right here, right? Okay, that's the same thing. What do you know about if you have two angles that are, what kind of shape are they on right here? They're on a straight line. So if you have two angles that are on a straight line, what do you know about them? They're supplementary, which means they add to be what? 180. Well, since we could rewrite this down here, you really don't have to though, okay? What do you think you know about if something is going to be the same side interior? What relationship do you think they have? How do you think I'd solve them? They are supplementary, therefore their sum, or when you add them together, it's equal to what? 180. Okay, that's the rule here. Sum is equal to 180 degrees. Okay, and remember the sum means add them together. So the sum of same side interior angles, or if you add together the two same side interior angles, it equals 180 degrees. Okay, so these are the three different angle relationships that we're going to look at today. Do we have those written down okay? You good? Okay, now we're actually going to do some problems. Okay, and we're going to figure out first what types of angle relationships they have. Then we'll know how to set them up. Okay, so this is going to be kind of like your reference page. Okay, so for example number 1, okay, hopefully you can see that, yes. Okay, for example number 1, if I give you, we're going to have two parallel lines. Now this one I'm going to turn them a little bit, okay, but that's okay. Okay, we're going to see these are parallel. Technically, for you to know that things are parallel, they have like a little triangle on them. And if they have the little triangle on them, they're for sure parallel. Honestly, when we write your tests and quizzes and worksheets and stuff, sometimes they forget to put the little triangles on there. So if they look like they're parallel, then you can just assume that they are. Okay, sorry that we sometimes forget that. And these are going to have a transversal going through them. Okay, so looking something like that. And let's see, I'm going to label right here, I'm going to label this 60 degrees. And right here, I'm going to label it as, in parentheses, 5x plus 5 degrees. So 60 degrees and 5x plus 5 degrees. Let me make it a little bit bigger so you guys can see it. So if you look at this angle relationship, what type of relationship do these have? Are these vertical, corresponding, or same side interior? Corresponding, okay? You know they're not vertical because they're not like attached to each other just on the other side of the X. They're not same side interior because this is an interior. So kind of by default, these are corresponding, okay? So if you have corresponding angles, now you don't have to label what type they are, but I would, especially in your notes, okay? Corresponding angles, what did I tell you was the rule for solving these? set them equal to each other. So we would set 60 degrees equal to 5x plus 5 degrees. Oh, I'm sorry. And your instructions here were solve for the variable, or solve for the letter, solve for the variable, and missing angle. Okay, so you're actually going to have two parts here. First, I want you to find what x is, and then I want you to plug it back in to find what the whole thing is. So 60 is equal to 5x plus 5. How do I start undoing that? Subtract the 5, right? You subtract the 5, that gives us 55 is equal to 5x. Then how do I get x by itself? Divide both sides by 5. And if we divide both sides by 5, what am I going to get? 11. So that's part of your answer. Part of the answer is that 11 is equal to x. Then I want to find this missing measurement. So how would I find that missing measurement? Plug it in, exactly. Okay, and remember, you're plugging in for x. So here you would do 5 multiplied by 11. Anytime you multiply, or anytime you plug something in, you want to put it in parentheses, and it's probably going to be multiplied. So 5 multiplied by 11 plus 5. What is 5 times 11? 55. Plus 5 degrees is equal to 60 degrees. Now, did you really have to plug that back in?
No.
Why? Right. So if this is corresponding, you could have just written that it was 60. But this is a really good way of checking your answer. So you should probably do that too. But you can check to make sure, yep, I got the same answer. So those are your two angles. Okay, let's try another one for number 2. Okay, example number 2. I would like you to solve for the missing angle if we have two parallel lines again. Okay, and this one I'm going to draw a line going through like this. And if I tell you that, let's see, this angle is 105 degrees, and this one's just a question mark. We got a little lazy and just didn't even write the x. Okay, it's just a question mark. So this one we're really only doing one part. I just want you to find what the missing angle is equal to. What type of relationship do these have? Are these vertical angles, corresponding angles, or same side interior angles? Same side of the transversal, so those are on the top, and they're both inside the parallels, so same side interior. Same side interior angles. Now, you can either remember what to do with those, or you could realize that this 105, where would be its corresponding angle? Corresponding to here would be right here. So would you agree that this is also 105 degrees? Then my question mark, so what I don't know in 105, together make a straight line. So that means there's some, or if I added them together, so question mark plus 105 is equal to what?
180.
180. Okay, which is what same side interior angles do. Okay, 105 plus the question mark is equal to 180. Then to get the question mark by itself, you would subtract 105. So if you subtract 105, you would get that your missing angle is equal to what? 75 degrees. So this one you really only have one part to find because it's just all there was. Question on how I did that? No? Okay, a couple more. Let's try number 3. Okay. For example number 3, how about if I have, let's see, let's go 2 parallel lines going this way, and our transversal is going like this. And I tell you, let's see, that right here is 2x plus 9 degrees, and right here is 4x minus 41 degrees. So 2x plus 9 degrees and 4x minus 41 degrees. relationship do these two have? These are vertical angles, right? So vertical angles is if you turn it a little bit sideways, it's like the right across from each other and they're making an X. Okay, so vertical angles. And do we remember what's the relationship between vertical angles? You set them equal to each other, right? So it doesn't matter which one you write first, but 4x minus 41 will be equal to 2x plus 9. I like it better if we move the letters first. You could move the numbers, but I would prefer to move letters first or variables first. So which one would you move, the 4x or the 2x? The 2x. You always want to move the smaller one, otherwise you're going to have to deal with negatives, which you still can get the right answer. It's just kind of annoying. So 2x minus 41 is equal to 9. So those canceled out. Then to move the 41, you're going to add it to both sides. And that's going to leave us with 2x is equal to 9 and 41 is 50. Got x by itself. You divide both sides by 2. And so we're going to get x equals 25. Now, does that tell me what my actual measurement is equal to, though? No. So this one you're going to have to go and plug back in. You can plug into either one, does not matter. Okay, which would you prefer to plug into, the 4x or the 2x? Doesn't matter. Some of you try both. I'm going to do this 2x. Okay. And remember, when you have 2x here, you're doing 2 multiplied by 25 plus 9. So 2 times 25 is 50 plus 9. 50 plus 9 is 59 degrees. Now, if you chose to plug into 4x minus 41, did anyone plug into that one? Yeah, did you also get 59 degrees? Okay. Well, if you do that one, you'll also get 59 degrees. Okay, and that works because remember, these are equal to each other. So if you wanted to check your answer, you could always plug into that one just to make sure. Questions so far? So hopefully not too bad yet. Okay, we're going to do 2 more, and then we'll be done. Okay, for example 4. Okay, for number 4, let's go parallel lines going left and right. And this time we're going to have a transversal going down and to the right. So for this one, if I tell you that the top here is 5x plus 10 degrees, and this bottom part right here is 4x minus 10 degrees. So 5x plus 10 and 4x minus 10 degrees. What type of relationship would you say that these two have with each other? These are same side interior. So same side of the transversal inside the parallels. So these are same side interior. And what do we know about same side interior angles? The sum of them, so when you add them together, they equal what? 180. Doesn't matter which one you write first. So 5x plus 10 plus 4x minus 10 is equal to 180 degrees. So we're going to start by combining your like terms. So add together your 5x and your 4x. 5x plus 4x gives you what? 9x. Then if you add together positive 10 and negative 10, what does that leave us with? 0. You don't have to write a plus 0. It's just 9x equals 180. Then to get x by itself, divide both sides by 9. We divide both sides by 9, we get x equals 20. So this one, x is equal to 20 degrees. Now, how do I solve for these? Plug it in. Okay, so if I plug into this one, that would give you 4 multiplied by 20 minus 10. So 4 multiplied by 20 is 80. And 80 minus 10 is equal to 70 degrees. Now, are you done? No. Why are you not done? Because these aren't equal to each other. Okay, so you actually have to find this one as well. Okay, so if you plug into that one, you're going to get 5 times 20 plus 10. 5 times 20 is 100. Plus 10 is 110 degrees. Now, is there maybe an easier way that you could have done this one to find out what it was instead of plugging in?
Yeah,
You could do 180 minus the one that you already found. Okay, but either way, it's going to work because these are supplementary. So supplementary means if you added these two together, you would equal 180. And that works. Okay, last one we're going to do, number 5. Okay, for number 5, if I give you two parallel lines that are running straight up and down, and a transversal going through here. For this one, I'm only writing it this way because there's one like this on your homework, and I don't want you to get horribly confused. They're written sideways, so you just kind of like turn your paper a little bit. And this is x plus 5 degrees, and this one is 75 minus x degrees. So they're written kind of sideways, and I'm only doing that because some of yours on your homework look like that, so I don't want you to be thrown off by the like sideways writing. So x plus 5 degrees and 75 minus x degrees. What type of relationship would you say these two have? They are on the same side, but one is inside the parallel, so it would be interior. One is outside. Do we have a relationship where there's one of each? They're corresponding, right? Okay, they're both on this outside, or they're both on the right side of their parallel line, so these are corresponding. So corresponding angles, what do we know about how to solve for corresponding angles? They are equal to each other, right? So set them equal. So x plus 5 will be equal to 75 minus x. You're going to want to move the x. Do I want to move the positive x or the negative x? Probably want to move the negative x because we don't want it to stay negative. So really this is going to add x. And technically there's a 1 in front of that. There's a 1 in front of this one too. So 1x plus another x gives you 2x, plus 5 is equal to 75. Then to move this 5, you're going to subtract 5 from both sides. That leaves us with 2x is equal to 70. And to get x by itself, you divide both sides by 2. If you divide both sides by 2, it gives us x is equal to 35 degrees. First part is x is equal to 35 degrees. Now, last thing we need to do is find our missing angle. So to do that, you're going to plug in. Okay, so I'm going to plug into this one. You could plug into this one. It does not matter. Okay, so x was 35 plus 5. There's nothing being done to that in parentheses, so they basically just go away. Okay, so 35 plus 5 gives you an answer of 40 degrees. Do I need to plug in the other one? No. Why do I not need to plug in the other one? Because they're equal to each other. So they're both 40-degree angles. Okay. Homework on this is you guys are going to do worksheet 5.6a, so it's just one side. Okay, and there are 12 problems on that, so you're going to do all of them. Okay, so just first figure out what type of angle relationship they have, then you can solve after that. Anyone have questions?